Yep. All right. We're coming back here and we're going to talk about more limits that involve infinity. So the last limits we looked at, we were driving x to infinity. But what happens when you're approaching a number like b? So b is going to be a real number and you get infinity as your answer, right? So I'm not going to infinity and getting infinity, but I'm going to a number and I'm getting infinity. What the heck does that mean? Well, think about it, right? And I got a couple of examples here. If x goes to b from the right and you get negative infinity, so here's like b, right? And I didn't draw the x-axis, but if I'm coming to b from the right and I get negative infinity, that means the graph's going to dip down, right? What does that look like to you? Okay. Or that's what that blue wording there is. Or what about as I go to b from the right and I get positive infinity? So as I'm going to b from the right, my functional values maybe are doing this, right? Looks like that. What am I kind of describing here? And hopefully you're saying vertical asymptote. All right, so let's take a look at this example. As we go to b from the left, so as we go to b from the left, maybe we go and we get negative infinity. So that's kind of graphically what would be happening. Or maybe we go to b from the right and we get positive infinity. All right, I'm sorry, b from the left. So b from the left and we get positive infinity. That's kind of happening. Again, vertical asymptotic behavior. Or maybe we go to b from both sides, right? So as we approach b from both sides and we get negative infinity, all right? Or maybe we approach b from both sides and we get positive infinity. So I'm trying to give you like a graphical depiction of each one of these scenarios. Basically means you have a vertical asymptote. So if you do a limit of some function as x goes to a value like 7 or 5 or -1 and you get an infinity, that means that you have a vertical asymptote going on. All right. Now, if you think about it, that's not really telling you how to get the vertical asymptote, right? So like you almost kind of stumble upon it. Like you do the limit of f(x), x goes to 2 from the right, and you get positive infinity. Okay, so there must be a vertical asymptote at x equals 2. It didn't tell you how to find 2. So, but you already know how to find vertical asymptotes. You did that back in the day. All right, so how? Well, you basically see where the function is not defined, and depending on the function, depends on the different ways to do it. All right, so let's look at a couple of problems here. All right, we'll start with a sticky wicket here. So say we had f of x and it was equal to the ln, natural log base c, right, of x plus 2 minus 5. So hopefully you know or you remember that you cannot input 0 or negatives into a log function because they're either undefined or not real, all right? And that the domain of this is really going to be, in this case, anything that makes the inputs positive, right? So if I looked at this, I'd say, all right, the x plus 2, that's going to have to be greater than 0, so then I'm going to get x greater than -2. But it actually turns out that this -2 is actually going to be your vertical asymptote. So to figure out where a log function is not defined, you basically set the parentheses, or maybe better said, the input equal to 0. All right, so to find VA, right, we would just set that input equal to 0, and we would get x equals -2. So that's me just using pre-calculus to find my vertical asymptote, right? If you're unsure of that, right, you know what we're going to do. We're going to go ahead and we're going to graph it. All right, so I'm going to pull up this guy, f of x equals the ln of x plus 2, and then minus 5, and maybe kind of adjust the window a little bit, and you can be like, oh yeah, it looks like, let me just put the vertical asymptote in there. It looks like, yep, there's a vertical asymptote at x equals -2. So now what if I wanted to do the limit as x went to that asymptote, just to maybe further describe, be like, maybe I don't know that it's going down forever. Maybe it might be going up forever. So I want to do the limit to figure that out. Well, all right, that's what we're going to do here. So I'm going to come over here. I'm going to say, okay, let's do the limit of f of x as x goes to this vertical asymptote. Now, if you think about it, I can only really approach this guy from the right because that's the domain of this log function. It's not defined for values that are less than or equal to -2. So it only allows me to approach it from the right. So then I would get the limit as x goes to -2 from the right of this thing. And now there's really no direct substitution method here that's going to work, right? Because if you chuck in -2, you get ln of 0 that's not defined. So the best way to do a limit problem involving logs, at least in my estimation, is kind of to visualize the graph. Okay, so if I visualize the graph, which I just had up, and I'll check it up again, right, I can see that as I go to -2 from the right, my functional values are going to go to negative infinity. All right, so then my limit would be negative infinity. And this is an example of, I just took the limit of a function as x went to a value, in this case from the right, and I got an infinity. So that's describing, right? Here's this x value of -2. And as I go to -2 from the right, I'm getting negative infinity. I'm able to see this, right, based off of this. Now you're like, well, you kind of did a little bit paradoxical circle there because you used the graph to figure this out. And you'd be correct in saying that. But you could also have done numerical estimation for this guy if you weren't able to see the graph, and you would have saw that the values were going to negative infinity. So not my most favorite example. Nonetheless, we had to do it. Let's take a look at the next one. Maybe this one's a little bit more comforting. Like, what would I do if my function was this? Right? I want to describe what's going on at the vertical asymptote. So first off, does it have a vertical asymptote? Well, now this is a different deal. This happens to be a rational function, right? It's a polynomial divided by a polynomial, right? Or I can even say, more generally speaking, a fractional function. So fractional functions can, emphasize on can, have a vertical asymptote when the denominator is equal to 0, because that would make them undefined. So I can come over here and I can set the bottom equal to 0. And so the only way that happens if x plus 1 is 0. And so I get x equals -1. Is that going to be my VA? Well, it turns out it will be, but I don't really 1000% know. I mean, I know, but maybe you don't. Maybe it's a hole, right? How do I know it's not a hole? So let me go ahead and observe the behavior at this value from the right and the left and see what I get. So what does that mean? Let me take the limit of g of x as x goes to -1 from the right, and let me take the limit of g of x as x goes to -1 from the left. So that would be the limit as x goes to -1 from the right of 1 over x plus 1 squared. And you're like, all right, this I guess can kind of use stuff we used before. If I chuck -1 in here, I get 0 in the bottom. And if you remember, right, number over 0, that's not an indeterminate form. That means the limit doesn't exist, but we have a procedure, and that procedure is to use tiny, right? So instead of writing 1 over 0, I'm going to write 1 over tiny, and the question is it positive or negative tiny? Well, if I'm going to -1 from the right, pick a number to the right of -1, say 0, 0 plus 1 is positive. Oh, by the way, I'm squaring it, so really that's not even going to matter. So this bottom's always going to be positive. So 1 over positive tiny is going to be positive infinity. At least that's how we interpret it. And hopefully you're seeing that it's actually not going to matter as I go to -1 from the left, right? Because even though inside these parentheses, this would be approaching 0 from the negative side. So it'd be like 1 over negative tiny, but quantity squared. So I'm still going to get 1 over positive tiny. So I get this. So now again, now this is me without even seeing this graph, able to realize that at x equals -1, as I go in from the right and from the left, this graph is going up forever, which is describing the behavior at that vertical asymptote. So if I come over and take a look at the graph, all right, so let's change this guy up here, and let's do 1 over x plus 1 quantity squared, right? And then let's put the new vertical asymptote, which is x equals -1. You can see, yep, there it is, right? As x goes to -1 from the right and the left, your corresponding functional values are going up forever, describing the behavior at that asymptote, which is pretty neat, okay? Let's do one more question, which wasn't in your notes, but I wanted to do it regardless because it's a good one. All right, so let's take a look at this guy. So let's do g of x, and I'm going to say it's equal to x plus 2 over x squared minus x minus 6, right? So you're like, okay, want to describe the behavior to the left and to the right of each vertical asymptote, or maybe even find the vertical asymptote. So again, it's a fractional function. It's a rational function. Right, so they are undefined when the bottom's equal to 0. So I would set the bottom equal to 0. And then hopefully I can factor this, and it looks like I can. It looks like x minus 3 and x plus 2 would be the factorization of that, right? And so I'm going to get x equals 3 and x equals -2. So you might just say, hey, I'm going to call it a day. And this basically, I got it, right? So the two VAs are 3 and -2. So, all right, so maybe you're thinking that. So all right, let's graph it just to check our work. All right, so here we go. I'm going to put the new function in, and we got x, parentheses here, x plus 2 divided by x squared minus x minus 6. All right, get rid of this because that wasn't the asymptote. And you're like, whoa, wait a minute. So we just got that we had asymptotes at 3, right? So that certainly looks like that's 1. But then we also got -2, and it doesn't look like there's an asymptote there. In fact, there isn't an asymptote there, right? So you're like, well, what the heck's going on? Well, if I am to click right there, you can see what's going on. There's a hole there. So yeah, it made the function undefined, but it doesn't mean it's guaranteed to be an asymptote. In this case, there's a hole. So when I go to do the limit, as x goes to -2 from both sides, I'm going to get a number, whatever the y value of this hole is. As opposed to when I go to do this limit here, as x goes to 3 from both sides, coming in from the right, I'm going to get positive infinity. Coming in from the left, I'm going to get negative infinity. All right, there's kind of a simple way you can see this without doing crazy calculus, right? So, and I'll kind of show you that. So if I went ahead and simplified this fraction, right, because this was x plus 2 over x, right, x plus 2 times x minus 3, notice you can cross these out. And so this ends up just being completely simplified, this. And if you remember, the 3, x equals 3, that was your VA, where here, this was your hole. Now, how could I have seen that? Well, if I plugged 3 into the original function, I would have got number over 0, which tells me I'm going to get a VA. And if I plugged -2 into the original function, right, I would have got 0 over 0, which actually tells me that there's going to be a hole there. Right? When you can cross out like factors like this, the value of x that makes that factor 0, which in this case is -2, is going to produce the 0 over 0, which graphically is going to relate to a hole. Now, I'm going to ask questions like on your test, hey, describe the behavior at each one of these points. So in other words, I would want you to do the limit of g of x as x goes to 3. You would have to know that you're going to have to do one-sided limits because you're going to get number over 0 in that case. So you're going to do one-sided limits and you're going to use tiny. And I'd also want you to do the limit of g of x as x goes to -2, which in this case you'd get 0 over 0, and the thing to do there would be to factor, and you'd end up just getting an answer, which would tell you there's a hole. So I'm not going to do this in the video. You should do it. You should do this problem, see what you get. You know graphically what you should get, and you should also do this and see what you get. All right, and then see how it matches up to the graph that I just showed you. Okay, all right, peace out.